Now that you have the basics of organic chemistry, let's talk about our four major groups of organic molecules: carbohydrates, lipids, proteins, and nucleic acids. We're going to start out with carbohydrates. First off, let's look at the formula for a carbohydrate. All carbohydrates reduce to the formula 1 carbon, 2 hydrogens, 1 oxygen. In other words, it's a carbon that has a water or it's been hydrated. Yes, organic chemists have senses of humor. So if you look at a formula for a carbohydrate, then if you count them up, you should be able to see CH2O. So for example, if I see a molecule that has a formula of C6H12O6, that reduces down to CH2O. Now the functions of carbohydrates are to store energy and for structure. They also communicate, but we're not going to worry about that function in this class. Now carbohydrates can hook together to form huge macromolecules or huge big molecules. So let's look at a monosaccharide. So here we've got a glucose and a fructose. They're both 6 carbon molecules. 1, 2, 3, 4, 5, 6. Okay, and you'll notice there are 6 oxygens. 1, 2, 3, 4, 5, 6. And if you were to count all of them, including the hydrogens that haven't been drawn in, there are 12 of them. Now fructose also has the same molecular formula, but you notice it looks a little bit different. Now these are considered monosaccharides. Okay, saccharide comes from the Greek for sugar or sweet. So these are monosugars. Now we can hook 2 of them together to make a disaccharide. So you'll notice that in this process we're going to take a hydroxide group off of the glucose, we're going to take a hydrogen off of the fructose, and if you put them together, what do you make? Water. Okay? And they're hooked together with the remaining oxygen. So I have a glucose over here, I have the fructose over here, they're hooked together with 1 oxygen, and I have a water left over. This is called a dehydration reaction because I'm removing water. Okay? And I've made a disaccharide. Now I can keep doing this and make a polysaccharide or a big carbohydrate that's a chain of monosaccharides. Now with the removal of water, would this be an exergonic reaction or an endergonic reaction? Because we're going from 2 small molecules to a bigger molecule, then it's exergonic, requires energy. Now, we can reverse this. In biology, most reactions are reversed. We can take this water, put it in here, break these 2 molecules apart, arrive at 2 monosaccharides. We call this a hydrolysis or hydrolytic reaction because we're using water to break apart the molecule. Lysis is Latin for breaking.